today's session. The highway survey session. Before we continue, I would like to confirm if you are all in. When I will call upon your name, you say you are present. Okay? Douglas Nkono, Brian Kukobe, Gideon Giroux, Emmanuel Kuplana, Brian Kukobe, Dennis Kuto, Naomi Kiri. Okay, I can see most of us are already. So, our today's session title, today we are going to learn about establishing ground level by computation of volumes. And so before we start our today's session, I would like us to review what we learned on our last session. What did we learn on our last session? Kindly raise up your hands. What did we learn on our last session? Conducting size survey. What did we say is the first step? What did we say is the first step? Yes? We have to plan for the size Yes, can you appreciate him? So when we say a cross-section is a profile view of the ground perpendicular to the center line of the baseline, and it indicates ground elevations of points of change in the ground slope. Are we together? Yes. So that's basically the definition of a cross-section. And when we say cross-section, when calculating a cross-sectional areas, this is first calculated after the computation of volumes of earthworks. Are we together? Okay. So let us look at the types of cross-sections. What are some of the types of cross-sections? Yes? We have two-level section. Another one? Yes? Multi-level section. Another one? Yes? Three-level section. Another one? Yes? Level section. And the last one? Yes? Side hill. Side hill, two-level. Two-level section. So basically, these are some of the types of level sections that we have. We have the level section. We have the two-level section. We have the three-level section. We also have the side hill, two-level section. And we also have a multi-level section. Are we together up to that point? So in our case, in this lesson, we are going to look at a level section. In our case today, we are going to look at the level section. What do we understand by the term level section? When we say level section, what do we mean? Yes? Yes, this means that this is a section when the ground is leveled along the traverse. So basically, when we say level section, we mean that it is a section whereby the ground is leveled along the traverse. So in form of a diagram, let me turn it like this. So this is our level section. This is our level section, and this side is the height of the embankment. So when we denote height, it is the height of an embankment. And then V here stands for the width of an embankment. And then S into 1 this is the side slope. Are we together? This is the side slope. So that's basically a sketch of level section. And we say that a level section is when the ground is level along the tracks. Are we together? So now, I want us to look at an example on how to calculate a cross-sectional area using a level section. I want us to calculate on that. Have you kindly write down this question? So that's our question. It says, calculate the cross-sectional area of an embankment 10 meters wide with a slope of 2 to 1. The ground level is level in a transverse direction to the center line, and the central height of the embankment is 2.5 meters. Who can help us in simplifying that question in form of a diagram? Who can help us in simplifying that question in form of a diagram? I want one of you to go to the board and maybe draw for us a diagram for that. Yes?
Given a question, calculate the cross-sectional area of an embankment 10 millimeters wide does not put at 1. The ground is level in a transverse direction to the center line. The central height of the embankment is 2.5 meters. So a level section is like this. Then now the given it's width, it is the breadth from this point to this point. The difference is 10 meters. Then you have been given the side square, 2.1. Then you have made a side square, 2.1. Then you have been given this height to be 2.5 meters.
Can we appreciate him? So basically, he has simplified this question to us in form of a diagram. So let's now calculate the cross-sectional area of this level section, having been given the width to be 10 meters, the side slope to be 2, measure 1, and then the height to be 2.5 is 2. Are we together? So we use 2 times our height, 2.5 into 2.5. Now I want us to start by calculating this of the bracket. What do we get when we say 2 times 2.5 plus 10? 15. Now when we get 15, we multiply by 2.5. What do we get? That's 7.5 meters square. So basically, this is our sectional area for this level section. Are we together? So I want us to look at another example before we finish. I want us to look at another example. Determine the cross-sectional area. So we've been given our width is 25 meters, and then our side slope is 2.3 to 1. And then our height is 6 meters. Using our same formula, B times side slope times height into height. Our B in this case is 5 plus our side slope, which is 2.3 to 1. In this case, we use 2.3 times our height is 6 into 6. Are we together to that point? So can you calculate this? 25 plus 2.3 times 6. 25 plus 2.3 times 6. What do we get? 38. Now after we got this 38.8, we come and multiply by our height, which is 6 meters. What do we get? Yes? 232.8 meters square. This is now our cross-sectional area for our embankment that featured the trapezoidal shape. Are we together to that point? So, as we summarize our lesson today, I want you to write down in a piece of paper 3 things that you've learned today. 3 things that you've learned today. And then 2 things that you didn't know. 2 things that you didn't know. I've said you write down for me Three things that you've learned today. Two things that you didn't know. Two things that you didn't know. And then one thing that you are surprised that you've known. How? One thing that you are surprised that you've known. Three things that you have learned today. Two things that you didn't know. And then one thing that you are surprised that you've known today. I'm giving you 1 minute. Are you through? Are we through? Can one of us tell us three things that he or she has learned today? What have we learned today? Yes? Types of cross-sections. We've learned types of cross-sections, and we say what are some of the types of cross-sections. Kindly raise up your hand. Yes? Level section. Yes? Two-level section. Yes? Three-level section. Yes? Multi-level section, and the last one? Yes? Cycling two-level section. What else have we learned today? What else have we learned today? Yes? How to calculate a level section. And then we define what a cross-section is. What did we say a cross-section is? What did we say a cross-section is? What is a cross-section? Yes?
These are proper details of the ground of the regular to the center line of the baseline and indicate ground elevations at points of change in the country.
Okay, can we appreciate him? So basically a cross-section is a profile view of the ground perpendicular to the center line or baseline, and it indicates ground elevations at points of change in the ground slope. Are we together? Anyone with any question up to there before we end our session? Anyone with any question? Are we all good? So I want you to leave you with an assignment. go and calculate the cross-sectional area of an embankment with a base width of 18 meters, a side slope of 1 to 2 on the left side, and a vertical height of 3.5 meters. The ground level is in a transverse direction to the center line is level. I will collect that assignment on our next session. So, can you hand over your attendance? So, that's the end of our session today. Let's meet on our next session. Thank you.